Naimbag nga aldaw, engineers of the future. Welcome to your online class in Engineering Utilities 2. I am your instructor, Daryl J. Ambleby. In this video, I will discuss pressure difference, specifically one type of pressure difference which is static head. What is pressure difference all about? When forces acting on a fluid are unequal, molecules in the fluid move in the direction of the least pressure. Fluid flow is caused by a pressure difference in the fluid. A fluid will always flow from a higher pressure region to a lower pressure region. A pressure difference must exist at a plumbing fixture to cause water to flow. That is, water pressure at the fixture must be at a higher level than atmospheric pressure for water to flow from the fixture. Pressure difference, denoted by delta P, is the driving force of fluid flow. As I have said, one type of pressure difference is static head, which is the pressure difference from elevation change. So how do we compute for static head? Static head in PSI, or pound per square inch, is equal to negative 0.433 Z, where Z is the vertical height expressed in feet. Static head in kilopascals is equal to negative 9.8 Z, where Z is the vertical height expressed in meters. By convention, the vertical height Z is positive if elevation increases from the station with the known pressure. That is, the station is higher than the station with the known pressure. And Z is negative if elevation decreases. Pressure difference is negative, or a loss, if the elevation change from the known pressure is upward, or a positive Z. And pressure difference is positive if elevation change is downward, or a negative Z. Pressure change in a plumbing system from elevation change may be computed by multiplying the vertical height of the fixture outlet to the street main, which has a known pressure, by the pressure the water creates per foot. Let's have an example. A plumbing fixture outlet is 24 feet above the water service line. Pressure available at the water service is 45 psi. Determine the change in pressure from elevation and the pressure available at fixture. First, we need to solve for the change in pressure from elevation, or simply the static head. We have two formulas for that. What are we going to use? We're going to use a negative 0.433 Z because the units given in the problem are feet and psi. What is our Z? Our Z is 24 feet. And it's positive because the plumbing fixture outlet, which has an unknown pressure, is higher than the water service line, which has unknown pressure. Calculating the static head is equal to negative 10.39 psi, or a 10.39 psi loss. Change in elevation is upward from known pressure, so delta P, or the static head, is negative. Second, we need to solve for the pressure available at the fixture. And that is equal to the algebraic sum of the pressure available at the water service, which is 45 psi, plus the static head, which is negative 10.39. Calculating, that is equal to 34.61 psi, which is the pressure available at the fixture outlet.